Vureal that does really interesting work, and actually they have raised a good amount of money recently. So congratulations on that.
Thank you.
And we are looking to hear your updates.
But a little bit of updates, about Vureal. We started the company in 2016. Our main focus is on transfer technology. So we develop a transfer solution to integrate micro LEDs on the surface at high yield and high throughput. Uh, and actually, we raised the money to scale our production. We have been working with automotive company for a while, and if you came to CES this year, we took a slightly different approach to micro LED marketing. And instead of offering a better, brighter display, we looked at micro LED, how it could solve some of the system implementation issues in the automotive, in the consumer. And actually, that message received much better than competing head to head with OLED. So you would hear a lot more around that line at SID from Vureal, how we are using MicroLED to solve the system issues. So, which is a slightly different approach, and is the area that other display technology has they have hard time. So that's been very helpful, especially on the automotive sectors, and you will see some good announcement in the next few months from Vureal. So back to the topic. Um, one of the things that we looked at the AR display is been something that is always next year, because we kind of chasing the ultimate solution and a fully immersive with fully surrounding awareness, all the beautiful things that we want. And that's always next year. It's just almost the fusion of the energy is the AR. We think there is a lot you can do somewhere in between. And if you, we published an blog about this a couple of months ago, and right after that, Mark Zuckerberg from Meta exactly repeated the same thing. That's the approach they're taking, which was a good testament that people think the same way. So that's kind of where this talk is about: is looking at what each application need and how we can address that at the cost performance ratio. So a little bit about the outline. I will review a bit our technology, discuss a bit of the different optics, different application, and then how we divided the AR category in three different areas and how we are addressing each of those areas. So this is kind of where the end goal is. You want to have a full surrounding awareness, adaptive HMI, eye tracking, everything, all these things. So this is the ultimate goal, and we know is going to be almost a year for future. So what we developed at Vureal, as I've discussed, is a printing process. So we take the LEDs and turn them to a cartridge. And the advantage of this process is that we can inspect the cartridges for yield, defects, performance, and we can make the cartridges smaller to make sure within the wafers they are uniform. And then we can use multiple cartridges to increase our throughput. So we can eliminate the yield performance relationship with throughput and break that, and therefore optimize each one of them independently. As a result, we got very high yield. Our throughput using exactly the same tools is 2x, more than 2x higher than other solutions. We manage the uniformity at the wafer and device level. Because of that, the compensation is much better, and we can relax some of the LED requirement, and therefore the cost and the production become much easier. Our solution allows to use majority of the wafer area and produce display. Therefore, the cost is lower as well. And this can be scaled to to larger substrate size. So one of the things that we are pursuing with some partners is developing Gen 6 and Gen 8 based on our solution that would be able to produce monolithic TV in the near future. So we use this technology even for
Reza,
AR. Yes.
can I ask you maybe to turn off your camera because it blocks some of your images at the bottom?
Okay.
Yeah,
Is it good?
perfect.
Okay.
Yep.
So we use this technology also for AR. Majority of the AR approach today is wafer to wafer bonding, which reduces the yield, uniformity. You've heard all about it, that there is a wafer mismatch between the LED